Alright guys, I want to walk you guys through a couple of the things that we did in class the other day. Remember, we only looked at two sections. We were looking at the sections of 1.2, of just section 1.2 itself. Section 1 was solving applications using simple interest, and section 2 was solving applications involving mixtures. Very, very similar. The two, we use tables to help us set up what it is that we're looking for. So a way to kind of think about this, we started first with the simple interest. And just as a reminder, simple interest, remember, uses the formula that interest is equal to principal times rate times time. So it's a multiplication problem. And again, your principal, what you're looking at here, that P stands for the principal, which is the amount of money that you borrow if you're looking at, say, a loan. Maybe you borrowed a certain amount of money for your student loans or a certain amount of money to buy a house, so to go into a mortgage. And then the rate that's used, you're given a certain interest rate to, tell you, that it's going to accrue 3.5% interest, which means when you go to pay back, say we're using a loan, for example, when you're paying a loan, say if you borrowed like $20,000 at a rate of, let's say 4% interest over a certain amount of time, that will tell you exactly how much money you're going to have to pay in interest. So just as a simple example first, let's say you borrow $20,000 at a rate of 5% interest. So that's the rate right here. 5% interest, we're going to multiply that 5%. Don't forget, we're going to use that decimal form to multiply that. So don't forget 5%, we're going to use 0.05. So don't forget in the multiplication problem to replace that percentage with the decimal always. And then over time, let's say you need to pay that back over 5 years, or if say you plan on paying that after 5 years. So we're going to use that time 5 years. So just in this simple interest equation, you've borrowed $20,000 at a rate of, let me make sure I typed that in correctly. Yeah. I'm going to make sure I didn't use too many zeros. $20,000 at a rate of 5% interest, and you are planning on paying that back over 5 years. It looks like you are going to pay an interest of $5,000. So that tells you how much money goes into interest. So you always want to make sure when borrowing money that interest rates are a certain amount. The lower the better, obviously. Whereas if that was only, say, a 2% interest, just to give you an idea of what that looks like, say you borrowed $20,000 at a rate of only 2% interest, so I'm going to multiply that by 0.02, and you plan on paying that back over 5 years, then again, what that's going to look like, 20,000 multiplying that by 0.02, multiplying that by 5 years, you're only going to pay $2,000 in interest. So over the life of the loan, you'll have to pay back $22,000. That's how loan companies get their money. But is those interest rates. So obviously always the lower the better. But now in these types of problems, what we're looking at is not just, saying, okay, well, if I borrow a certain amount of money, how much am I going to pay in interest? Instead, we looked at, in these situations, we were looking at somebody borrowing so much money from one company and maybe so much money from a different company, and we already know the amount of interest that they've paid, so we want to know exactly how much they borrowed from each company. So giving an example, I'm walking you guys through, let's say, I think we did most of the ones in the book. I tell you what, let's just go ahead and go through skill practice 1. We did this one in class, but for those of you guys that weren't there, this is what we did, and I'll walk you guys through this one again for those who already have that in their notes. Practice 1 at the very, very bottom of page 95 says this. It says, Franz borrowed a total of $10,000. So I'm going to go ahead and write that down, $10,000. Okay, that's his total. We know that he's borrowed $10,000. Part of the money was borrowed from a lending institution that charged 5.5% interest. So there's the first lending institution. I'm just writing these things down as I'm reading it. The rest of the money that he borrowed from a friend to whom Franz paid 2.5% interest. Okay, perfect. Franz paid his friend back, so that's this one. He paid his friend back over 9 months, and remember you need to use years in that calculation. So 9 divided by 12 months is 0.75. I will always give you that in the equations. If this shows up on, these questions, not if, but when these questions show up on next week's midterm, I will show you what that is in years. So be sure to use the years. And he paid the lending institution, so this one, after 2 years. Let's write that down. If the total amount of Franz paid in interest was so from both of these companies, he paid an interest of $735. So how much did he borrow from each source? Okay, so let's remember those things. So let me actually just create a new slide here. Let's see. Okay, so let's say that we put this into a table. That's what this is showing us, that helpful to kind of pull this apart. So the first part of the table, what we're going to do is we're going to call this first part the principal. So remember, that's the amount that is borrowed. And then this part, we'll talk about the interest. Okay, that's acquired to this. So the first fund, remember, is the 5.5% company that he borrowed from. So that's that lending institution. So we'll just abbreviate it as LI. That's the lending institution. And then in this part, the next section, the 2.5, that was his friend. So we'll just abbreviate that as FRI. That's his friend that we are looking at here in the second column there. And the last part of the column, we'll just draw this out as the total. So remember, the first row that we're looking at there, we titled that principal. Don't forget that the total amount of principal that Franz borrowed was $10,000. So we already know what that is. The second row of our table here says this is the interest that we're talking about. And remember, the interest that he paid, we already know that total as well, and that was $735. So what we're looking at in each of these, the other two columns, we're trying to figure out exactly how much did he pay to the lending, of the $10,000, how much did he pay to the lending institution, and how much of it went to his friend, or not paid, I'm sorry, borrowed is what we're looking at here. How much did he borrow from each? I mean, you want to look at that $10,000 and say, well, he probably split it half and half. He could have said $5,000 to the lending institution, $5,000 I'm going to borrow from my friend. But that isn't for sure. How do we know it wasn't $2,000 from the lending institution and $8,000 from the friend? There's no way of really knowing that, and that's what we're trying to figure out in these types of questions. How much did he borrow from each person? And that's just based on this total, and we can figure that out because we can do this. We know linear equations and how linear equations need to be set up, and we're going to use a variable to represent each of these companies, or in this case, the company and the friend. So we're just going to call the lending institution X. That's going to be our variable that we're trying to solve for how much, he spent or how much he borrowed from the lending institution. So then what we're going to have to do to figure out how much he borrowed from his friend is we're simply going to take $10,000 and subtract X, because that would represent the rest. If we call the lending institution X, then 10,000 minus X will represent how much was borrowed from his friend. But we also have to incorporate, then in the second row down there, the one that we titled interest, we have to incorporate how much interest is coming from each, company and friend. From each of these, we have to also incorporate over how much time that was accruing, that, how much time it took to pay that back. Remember that interest is gained with, time that passes. So what we have to do is we have to think about this, and here's where your problem is going to come from. Your linear equation is going to come from, is what you put down here in this second row. We have, again, that first, the lending institution is X, but don't forget your equation, that interest is equal to principal times rate times time. So we're going to put that into each box. So if we're trying to calculate the interest for that 5.5% lending institution, we're going to call that X, because that's the principal, right? Remember, that's what we just called the principal here in that first row. So that's our principal, times the percent interest. So remember, that's the interest rate. It's principal first, then the rate is the percentage, but don't forget we're going to use that decimal. So 5.5% interest written as a decimal is 0.055. And then we need to multiply that by the amount of time that we needed to, so that's the last part of that equation. the time that that accrued in order to pay back that lending institution. And if you remember from the problem, it said that he paid the lending institution back after 2 years. So we're going to use 2 in our problem here. Now with the friend, we're going to do the same thing with the friend and add that into part of this equation as well. So remember, the principal for his friend was 10,000 minus x. So sorry, I'm trying to write that in there, minus x. I'll draw it out a lot bigger on the next page there, our formula then. And then we need to multiply that, sorry, just what I have room with, by the rate. Remember, that's the next part, but the rate with his friend was 2.5% interest. So writing that out as a decimal is 0.025. And then the time it took to pay his friend back was 0.75 years, if you remember us writing that down on the previous page there. So here's what happens. What we have done is we have, now let me erase our little formula down here if I can. Nope, it's not going to let me, is it? Nope. Hang on. No, it's not going to let me. So what we have is let me circle these for you. Our, first lending institution that was, Franz borrowed money from. The second lender was his friend, but this plus this acquired a total of this. So in order to solve for x, that's what we're going to need to do, is we're going to need to take what's in that first box in our interest row, add it to the box in the second box, add it to the second box there, and then that's going to equal that 735. So let me go ahead and do that. Let me add another page here. See what that means. If x is equal to 2,000, that means, again, what we just solved for was this right here, was x. That means the amount of principal that was borrowed from that lending institution was $6,000. The friend, remember, was 10,000 minus x. So how much did he then borrow from the friend? Well, we know that 10,000 minus 6,000 is 4,000. So those types of questions are going to ask us how much did they borrow from from each lending institution, or in this particular scenario, it was a lending institution and then the friend. So again, it was simply just a matter of taking what we have, and let's say, remember our interest rate formula there. Our interest is equal to the principal times the rate times the time. But we don't know what that principal is from each, lending institution, so we can just call it x. If there's a second lending institution, it's just the total minus x, and then we'll be given the total. The second row that we'll put down there, we have to then incorporate the interest and the amount of time. So in other words, we have to incorporate this formula in that last row. So we need to make sure we put that into each box for each lending institution, and that's what we did down there with the 5.5% lending institution. We incorporated that and the amount of time, and then with the 2.5% friend, we incorporated that and the amount of time as well. So it's a matter of just adding those two together to get the total of interest that was accrued over that time. And so that will tell us how much was then borrowed from each individual or each lending institution. Okay, so I hope that helped with that one. Really, the second section that we looked at in that chapter, we looked at mixtures, and it's really pretty much the exact same thing. We were looking at section 2 on page 96. It says solving applications using mixtures. Mixtures, what that means is when we have a certain concentration of fluid, that it may not be 100% concentrated, it may be 5% concentrated, or it might have 8% concentrated, which means that it's only a part of that pure whatever it is. And that happens with drugs a lot of times. If a certain solution is only a 5% lidocaine solution, that means it's not pure lidocaine. It means that we've diluted that lidocaine so that the person is not receiving a overwhelming dose of lidocaine when injected with it. And so that's in any mixture. When you see that percentage, that's what that means. So, for example, let's say we take the example that's on page, actually, let's go to one of the examples in the back of the book. I think this is a really good example, and we did this one in class, but I think it was a great example to see kind of how this works, and it's very, very similar to what we did with our interest. that, if we have on number 12 just simply states that if we have a nurse that mixes 60 cc's of a 50% saline solution with a 10% saline solution to produce a 25% saline solution, well, then how much of that 10% did she use? Okay, so a lot of percentages in there and seems kind of crazy. But let's create another table. Now let's think about this for a second. Now if we have these mixtures, let's just say we call this, and let me get my pen ready here. So our table, we're going to have we'll call the first row the total amount, just like in our previous section that was the total principal, so the amount of money. Here we're looking at the amount of solution, so in liters or milliliters, or in this case cc's is what we're looking at in problem 12. And then we're going to talk about, since we're looking at saline, we're just going to call this I'll just call this, the one where we incorporate the percent saline. Okay. So what happens is, and again, in each case, we're looking at two different amounts of, or two different diluted substances. In this case, again, it's saline. So the first substance, we'll call that's the 10% saline solution. The second column, we're going to call this one the 50% saline solution that we were looking at. And remember, what happened then is we were adding these two, so we're simply just, I'm going to put a little plus on here, that we're adding these two to get a 2.5% solution, or I'm sorry, a 25% solution, not 2.5. My eyes are playing tricks on me. A 25% solution, which is possible. It's definitely possible, because if we incorporate the amount of dilution, 10% is diluted, too much, that it's only 10% saline, whereas 50% would be way too much saline. It's not diluted enough. We want something that's kind of a happy medium. So what we can do is we can add these two in order to get to that solution, but we want to know how much we can add of each solution in order to get to that. The great thing about this problem is it told us that we already know that the nurse had mixed 60 cc's of that 50% solution. So we already have that total. That 60 cc's is how much was used in that. And we want to know that, what was used of the 10%. That's what it's asking us. How much of the 10% solution should they use? So that's the one, and let me just draw a line here to show that that's our box down here. So we're going to call the 10% solution our x. Very similar to like we did in the interest rate formula in the last one. We're just going to call that one x, because the question is saying, how much of this solution do we need? So remember, it's like we have up at the top there. You can see the 10% solution plus the 50% solution is going to give us this. So really, in that last column there, if we're trying to make this 25% solution, we're going to say that this we'll call x plus 60. Since that's what it is we're simply just taking that amount of whatever the 10% solution was, adding it to the 60 cc's of the second solution, then it's going to give us a total. So it's just a matter of, again, this plus this will equal this. So the same thing that we have up at the top, and that's why we just call it x plus 60. But in the last row, remember, just like we did in the previous section, we have to incorporate the percent solution. That it's, yes, the first one is 10%. We can just call it x, and we can just guess, that, okay, well, maybe x plus 60 is equal to x plus 60. Yeah, we got that. But we just need to know how much would they use to make that a 25%. So here's how we do this. Don't forget that it's 10%, so it's just a matter of taking that x and multiplying it by the decimal of 10%, which is going to be, if you guys remember, that's going to be 0.1, and we're multiplying that by x. And then over here on the next row, we know that 50% is 0.5 written as a decimal, and since it's not x on this case, we already know the amount that we need for that, so we'll call it 0.5 times 60. And in that last one, we're incorporating the 25%, which is going to be 0.25 times x plus 60. Okay. So what we have here, the bottom row, remember where it says we're incorporating that percent saline solution, that's where we're going to get our linear equation. We're simply just going to add this box plus this box equals this box. So that's how we're going to write that out. So let's write that out. I'm going to add another slide over here and just go ahead and do so. Back to our table, remember we were just solving for how much solution was needed of that 10% solution to be added to the 60, and the answer for that was just 100 cc's. That's what we're looking for. Okay guys, so I hope that helped as I walked you guys through. I know those of you guys that were in class, those are some of the examples that we did in class, but I hope walking through those again helped you guys to see why we did the things that we did in class. If you guys have any specific instructions, any specific questions on the practice worksheet that you were given or just on anything that you all are studying, please, please, please let me know. But I hope that helps. All right, thanks. I'm going to write out just what we have. We have 0.1x plus 0.5 times 60. I'm simply just writing out that bottom row is equal to 0.25 times x plus 60. Okay, so there we have that entire thing written out as that equation. So we can go ahead and put some things together. I'm going to go ahead and put together the 0.5 times 60. So we're left with then 0.1x plus 30. So I went ahead and just multiplied 0.5 times 60 is equal to, and just while we're doing this, I'm going to go ahead and distribute over here on the right that 0.25 to each part of the parentheses over there. So 0.25 times x is going to be 0.25x. And then we're adding that to 0.25 times 60, which is 15. So now this linear equation, we can go ahead and moving some things to the other side of the equal sign. You all may do this a different way, but I'm going to go ahead and just move the 0.1 by taking 0.1x. I'm going to go ahead and subtract that, and that will cancel that out over here on the left side, and I'm going to subtract that 0.1 from the right side. Again, we got to do one thing, whatever we do to one side of the equation, we got to do on the other. So on the left hand side, that's going to leave me with 30. And on the right hand side, that's going to leave me with 0.15x plus 15. Now I'm going to go ahead and get rid of that 15. As we've done that before, we want to get, again, this x, where right here we want to get that by itself. So I need to get rid of that 15 first. Since it's being added, I'm subtracting it from both sides. That will cancel it from the right over there, and over on the left, 30 minus 15 gives me 15. So I'm left with 15 is equal to 0.15x. So to get x by itself, I will have to divide by that 0.15. Since x is being multiplied by since x is being multiplied by 0.15, I have to do the opposite again, which is division. So that will cancel that out over here on the right side, leaving me with x. But over on the left side, 15 divided by 0.15 is 100. So that leaves me with x is equal to 100. We'll come back to that table if we need to. So what our equation looks like is this. We have an equation that says x, and I'm just putting them together, those two boxes for right now. We'll distribute and combine like terms and all those things in just a second. But we have x times 0.055 times 2, and we are going to add that to the other institution, which is his friend in this case, and that was again 10,000 minus x times 0.025 times 0.075 or 0.75 equals that total $735. So now we have this linear equation, and what we're going to have to do is we're going to have to do some, like we know how to solve linear equations. We can combine like terms, we can use the distributive property. So just over here, right here, first I'm going to look at this first side where x is, just on the left side of the equal sign over here, but looking at that first term. Remember, the plus sign separates the second term there. So all I'm going to do is I'm going to go ahead and multiply 2 times 0.055. 2 times 0.055 is 0.11. So I'm going to write down what we're left with, 0.11x, because we can't forget this guy right here. So that's important for just this first term. Now what I'm going to do is I'm going to go ahead and put together some things over on that second term. So, this whole thing right here. I'm going to go ahead and multiply my two numbers, these two right here, just to put those together. So we're adding, and then right now we'll still leave in that 10,000 minus x, but let's just put together those two, 0.025 and the 0.75. So 0.75 times 0.025 is a big one there. I'll go ahead and write that in, 0.01875, and that all equals that 735. So here's our linear equation. We're starting to shorten it, but again, I'm just going to leave that 0.11x there on that first side of the plus sign as is, because then what I can do on the second side of that plus sign, that second term, I can actually distribute. What it says there is 10,000 minus x times 0.01875. So I'm going to distribute that 0.8175 to the 10,000 and to the x, just as we've done before. So leaving 0.11x where it is, plus, now let's distribute 0.01875 times 10,000 is 187.5, and then 0.01875 times x we know is just 0.1875x. So I'm going to say subtract, since that's a symbol between the 10,000 and the x, so I'm going to subtract 0.01875x. And that is all still equal to 735. So now we have, a little bit longer, lengthier, not really lengthier, we've distributed, so we've put some things together, but we have two like terms over here on the left side of our equal sign. We do have two x's that we can go ahead and put together. So I'm going to go ahead and do so. 0.11x minus, and it's minus because that's the symbol that's right in front of our 0.01875, so I'm going to go ahead and subtract that. 0.11 minus 0.01875 gives us, I'll write this down in yellow, 0.09125, and that's still our x, and we're still adding. We haven't done anything to the 187.5 just yet, and this is all still equal to 735. Now you can see this is kind of looking a little bit familiar. We know that now we're going to have to start moving things to the other side of the equal sign in order to get x by itself. So I can move that 187.5, since it's currently being added. I'm going to go ahead and subtract it, and I'm going to subtract it from the other side, 187.5. And so that's going to cancel it out over here, leaving us with our 0.09125x is equal to, and this is all underneath here, and I'm going to subtract 735 minus 187.5, and that gives us 547.5. Now to get x by itself, you guys know what we need to do. X is being multiplied by by 0.09125, so I need to divide it. That's what I'm going to do to both sides. And that will leave us then with x is equal to, let's see, divided by 9125 gives us 6,000. X is equal to 6,000. And that's what I'm looking for there. So a lot of stuff written on this page. So another thing, we've got, a lot of things, a lot of steps that are going to happen in these problems, but just like we've seen before, you guys know I'll make these problems worth multiple points apiece to make sure you guys get at least some credit for being on the right track. But x is equal to 2,000 in here. So let's go back to our